this off as 1.7, day 2. And for day 2, we're going to do combining like terms. Which like terms is one of your vocab words for tomorrow for your vocabulary quiz, right? If we are combining like terms together, like terms are terms with the exact same label. And I say label because sometimes you can have an x and you can have an x squared. Are those like terms? No, they're the same variable, but they're not like terms because they're not the exact same label. So we want to make sure that they're exactly the same if we're going to combine them together. Yeah, of course. I am more than happy to do examples to help you out. All right, so here is the basic idea. When you are combining like terms, it means that we are going to add or subtract, I guess, the coefficients, again another vocabulary word, of the term. Terms, plural, sorry. Terms, there we go. All right, so here is an example. Let's say I have 7x plus 4y minus 2x. What are the terms that are like terms up there, Jackson?
7 and 2x.
Yeah, the 7x and the negative 2x. So if I were to put those together or add those together, how many do I get, Jackson?
5x.
5x. Can I combine the 4y with anything?
No.
I'm just going to write it down. Okay? That's how combining like terms work. Now I want to clarify before I do an example. What I was saying was that if I had, let's say, 3x plus 5x squared minus 2x. What are the like terms here? What are they, Keegan?
3x and 2x.
Good. The 3x and the 2x, right? So I'm going to write my 5x squared down first. And then 3x plus a negative 2x is how much, Keegan?
1x.
Good. Plus 1x. All right. Does anybody remember what was our rule yesterday that told me I want to put that squared term first? I think that's the quietest the class has been in a long time. I asked a question and look how quiet it got. All right. So one of the rules yesterday, we said first it had to go alphabetical, which fits both of these. And then second, descending order, right? Which means we start with the biggest exponent and go down. That's why we wrote it in that order. Okay? All right. So here we go with example number 1. Now that we understand what we're doing today. Example number 1. So the first 6 problems or so on today's worksheet are all super easy. You're combining like terms. Your directions just say to simplify. All right, so let's say I have negative 5k squared plus 9 plus 10k squared. I can only combine the things with the exact same label on them. Good. Right. Very good. All right. So they took the negative 5k squared and the positive 10k squared are our like terms. We add those coefficients together and it got us 5k squared. And then we had a 9 left over, or plus 9. Example number 2. Since that one was so easy, how about what?
I have a question.
Mm-hmm.
So when it's 5k squared, why don't we like use that what's exponent. Why don't we do that and make it like 25? We don't know what to say it, so we can't times the k.
Right. This little 2 only applies to what's directly in front of it. What's directly in front of that? K, right? That's why. Yeah. All right, how about this one? Let's say I have 5a plus 7b minus 2a plus 10b. I have a's and b's up there. What do I want to start with? A, why? Yes, alphabetically it comes first. So I have a 5a and I have a negative 2a. Remember that sign goes with it, right? So how many a's do I have? 3a. Very good. Then I have a positive 7b and a positive 10b. Good. Plus 17b. Okay. Oh, okay. All right. All right, so here we go. Example number 3. Now, if you guys are good so far, let me just take it up just a wee little bit. You guys confident so far? We're doing good? Okay. So let's just take it up a little. Let's go with example number 3. We're still simplifying, but I'm going to get a little tricky on you. So, I know, how dare I? What if I have 7xy minus 3y plus 2xy. Oh, we'll just stop there. I was going to get trickier, but. Minus 3y, yes. So the same labels are the xy's, right? And the reason I'm doing that one first is because it has an x on it, which comes alphabetically before y. So 7 plus 2 is 9xy minus 3y. Awesome. You guys think everything's so easy. I like it. I like it. I like it. Math isn't supposed to be hard. Yeah, absolutely. No, it's not. All right. So you guys want it a little tougher? Let's do it. How about 5x squared y plus 2xy squared minus 3x squared y. Oh, I just moved that too far. Sorry, guys. My bad. There we go. Yes. So, the ones with the same label, what is it, Owen?
2x squared y plus 2xy squared.
Very good. Good job. So, the ones with the same label, we have an x squared y, and the other one with exactly the same label is a negative 3x squared y. So we have to put those together first. So we have 2x squared y. Then, left over without anything to combine with is plus 2xy squared. Okay, you guys did awesome on that one. Well, since you did so good on that one, how about this one? How about this one? Let's go with 3xy plus 4x squared y plus 5xy squared minus 2x squared y. What do you got? Very good. Trenton's right. Our like terms are this 4x squared y and negative 2x squared y. If we add those together, Trenton was right, we get 2x squared y. All right. So now technically we're done with those. I'm going to cross them out so I don't get confused of what I have left. Right? So I still have a 5xy squared and a 3xy. Can I add those together? Nope, they're different. And I'm going to tell you it doesn't matter which one goes in order. I'm going to put 3xy and then plus 5xy squared because it really doesn't matter. They're very close to each other. Okay? So, no, it depends on the situation. When you start to get more than one variable in the same term, how you write them in what order doesn't really matter. No. Good try, though. Okay, so far we've covered everything that would handle probably the first 11. Okay? There's only 15, so we're doing really good. Right? I want 2 more examples. All right? We can do 2 more, right? All right, here we go with example number 6. We're going to combine like terms. Let's say I have y plus y over 3 plus 2y over 3. Now, wait a minute. You know how many times have we practiced adding fractions this year already? So, when... You're close. All right, hey, listen. Whoa. Listen up. So we've added fractions. Every time we added fractions, we had to come up with a common denominator first. So we went like this, equals and a line, didn't we? What is our common denominator? All right. And what do I have to multiply this first one by to get a 3 on the bottom? This has a 1 on the bottom already. What do I have to multiply by? 3. Okay. What do I have to multiply this one by? 1. And what do I have to multiply this one by? 1, right? So I have 3y plus 1y plus 2y. 3y plus 1y is 4y, plus 2y is 6y over 3. Yes, we can reduce that to what? 2y. And we don't have to put it over 1 because 1's going to be there no matter what, right? We can just write 2y. So you guys all of a sudden saw fractions, and you said, oh, can't do it. We've been practicing this exact same thing how many times? Just because I put a letter in it doesn't make it any different. Same process every time. Huh? Do you want me to shut it? We'll compromise. I'll shut it a little. Okay? We'll compromise. It's all about compromise. All right. Example number 7. Say we have 3 times 2x minus 4 plus 5 times x plus 7. We have parentheses up there with a number in front. What is it we're going to have to do first to get rid of those parentheses? Distributive property. Good job, Keegan. Distributive property, which we practiced yesterday, and y'all told me it was super easy, right? So, 3 times 2x is 6x. 3 times negative 4 is negative 12. I'm to the end of that parenthesis, so I'm done distributing the 3. Come over here. I get 5 times x is 5x. Bless you. And 5 times 7 is 35. I'm to the end of that parenthesis, so I'm done distributing. Now what do I have to do? The parentheses are gone? Good. So I have this 6x right here, and I have a positive 5x. Good. So I have a negative 12 and a 35. What can I do with those? And if I add them together, I should get plus 23. Is that right? All right. So was that one hard? Yeah, it was pretty easy, wasn't it? So this is what you're doing on the very last three problems. So when you get your worksheet, this is the 13 through 15. Not that everybody refers to their notes and why I say that, right? All right. So here it is before I hand out your worksheet.